So taking a look at this gear train, we can actually calculate the individual gear ratios between each pair using these formulas. And so let's go ahead and start simple and just calculate the simple gear ratios between each individual gear pair. So let's start with the gear ratio of A to B. And we'll make A blue since it is, and we'll make B green since it is, just to color code it and soothe my OCD. And so the gear ratio from gear A to gear B. And to figure this out, I'm actually going to use my number of teeth equation right here. And we're just going to copy it and drop it in. And so the reason why I choose this one is because the only thing we know about these gears is the number of teeth. It does not tell us the diameter, the speed, or the torque. But as we'll see, we don't really need those other three to just calculate the gear ratio itself. So let's go ahead and draw ourselves a fraction. And let's see, what is the output? Well, the output is clearly gear B. Gear A to gear B to gear B, or gear A we'll say is the input and gear B is the output. So on top, we will put 12 teeth. And on bottom, we can put the input number of teeth, which is 20 teeth. And so to figure this out, we'll just type this into our handy dandy calculator. We'll say 12 divided by 20, and we get a gear ratio of 0.6. So we could say equals 0.6, or you could leave it as is because this is a gear ratio, or we could even simplify that gear ratio to be, what would it be, just 3/5. And these are all correct answers. Depending on what the question is asking, you might want one answer versus the other, but they're all basically the same thing, and that's kind of the point. And so from there, let's go ahead and find the next gear ratio, the gear ratio from B to C. So B is green, so let's go ahead and color code this to be B to C, so the gear ratio between gears B and C. And we're actually going to use the same equation. I'm not even going to waste time drawing it out or copying it out, putting it here. Let's just plug in our numbers. So the output in this case would be gear C. So we'll put that on top. So we'll put 5 teeth is the number of teeth for the output. And we'll make the input gear B. Gear B is turning gear C, so that makes it the input. So we put 12 teeth. And what's 5/12? Well, we'll just type it into our handy dandy calculator to figure it out. And what do we get? We get 4.1666 repeating. So we can just round that off to 4.1. No, not 4 point. I'm sorry. 0. Let's do that one more time. 0.417. And then, of course, we can very easily figure out the last gear ratio, and it's just the same pattern over again. The gear ratio from gear C to gear D. And so hopefully now you figured out the pattern. You put the output on top and you put the input on bottom. And so the output is the sort of ending gear, which is 20 teeth. So we'll put that on top, so 20 teeth. And on bottom, we'll go ahead and put, let me get the right color here, we'll put 5 teeth as the input gear, or what's driving it. And then hopefully you don't need a calculator to help you figure out what 20 divided by 5 is. It's just simply a gear ratio of 4. Or we could say equal to 4/1. And so now let's go ahead and find the gear ratio of the entire system. So let's go ahead and call that the gear ratio from, let's pick our right colors. A is blue, so A to D. What is the total gear ratio here using all 4 gears? Well, to figure that out, I'm going to just multiply all 3 of my gear ratios. So let me just go ahead and grab and make this video go a little bit faster. I'm just going to copy this one and paste it in right here so we can say, and I can go ahead and redraw that if I want to actually. But we'll go ahead and say gear ratio AB, and we'll multiply that, and I'll add parentheses in a second around each one. Multiplied by gear ratio BC, multiplied by gear ratio CD. Okay, and then I can add my parentheses to show they're multiplying, of course. And so to multiply these, what we're going to have to do is take each ratio and literally multiply them together. Before we just type in these numbers in our calculator, I want to show you something. So let's go ahead and grab the actual gear ratio that we wrote out, the teeth over teeth, the output over the input for each one. And let's look at what happens here. It's actually really cool. So I set 12 over 20, and I multiply it by 5 over 12, and I multiply that by 20 over 5. And so I'll multiply all three. And if you notice, what happens is we have 12 times 5 times 20 on top and 20 times 12 times 5 on bottom. But if you notice, gear B was used twice, one on top, one on bottom. So if I'm multiplying by 12 teeth and dividing by 12 teeth, those will cancel. 5 teeth cancels out in the exact same way. And in fact, this always happens in a gear ratio with idler gears, or gears in the middle between the input gear and the final output gear. If you think about it, it's going to cancel out. The middle gears will cancel themselves out in the system. And so we have gear A on bottom and gear D on top. So we have the output, D, divided by the input, A, which gives us the total gear ratio. And in this case, they happen to be the same size. So we can say 20 divided by 20 is just 1. So if I wanted to know the total gear ratio of the system, if I wanted to know the gear ratio of A to D, I actually wouldn't find each individual one, since they would all cancel out. What I would do instead is just look at the input over the output, or I'm sorry, the output over the input as we look at our formula. So we would say in, out, divided by in, and we would look at the total output and the total input. So we could set this equal to, well, what is the output? Well, that's gear D, so we would just say 20 teeth, and on bottom we would say just 20 teeth, which is exactly what we ended up with here. You can see how they canceled out, but since that's a rule, we can always ignore those idler gears and we get a total gear ratio of 1.